Did anything exist before the universe? We must look 13.8 billion years into the past, to the dense and violent origins of our cosmos. Physicists refer to the moment the expansion began as T0. This is the point where the equations of general relativity break down and time officially starts. Because time and space were born together, scientists have long argued that asking what happened before is mathematically meaningless. It is essentially the same as asking what lies north of the North Pole. If we accept that T0 is an absolute beginning, it leaves us with a startling conclusion that every star, planet, and galaxy we see today emerged from true nothingness. However, new data is challenging that absolute boundary. Powerful observatories are now capturing images of the early universe that contradict our standard timeline. The James Webb Space Telescope recently identified a galaxy named MOM-Z14, seen just 280 million years after the Big Bang. Its chemical signature, rich in nitrogen, suggests a level of maturity and star formation that current models say shouldn't exist so soon after the beginning. On a high-altitude ridge in Chile, the Atacama Cosmology Telescope has provided even deeper clues. It recently released the most detailed map ever made of the cosmic microwave background, the faint infrared glow left over from the birth of the universe. Within these maps, researchers found the Big Ring, a structure spanning 1.3 billion light-years in diameter. At this colossal scale, the structure is simply too large to have formed through the usual gravitational processes in the time since the Big Bang. Because these structures didn't have enough time to organize after T0, they suggest that our cosmic timeline is incomplete. We may be looking at physical evidence of a history that predates our own universe. To explain these anomalies, some theoretical physicists are looking beyond the 13.8 billion year limit, investigating models where our Big Bang was a transition rather than a starting point. Nobel laureate Sir Roger Penrose has proposed a model called conformal cyclic cosmology. He suggests our universe is just one aeon in an infinite series of beginnings and ends. Penrose's math shows that when a universe becomes completely empty in the far future, that state of low density is mathematically identical to the high density beginning of a new Big Bang. Evidence for this model might already be visible. Penrose identifies concentric ring-like patterns in the cosmic microwave background as gravitational imprints left over from the collapse of a previous universe. If this theory is correct, the background radiation of our universe isn't just a picture of its birth, it is a map of the gravitational scars left by the cosmos that came before us. Other researchers propose that the creation of matter is an ongoing process. Dr. Richard Liu has introduced a model that replaces a single Big Bang with a series of mini-bangs. These sudden acts of creation inject energy and matter uniformly across the cosmos. By acting as a source of negative pressure, these bursts could explain the acceleration we currently attribute to dark energy and provide the seeds for early galaxy formation. Alternatively, the field of loop quantum cosmology suggests that space cannot be crushed into a single point. This prevents the universe from ever hitting a zero state, leading instead to a big bounce. In this model, a prior universe collapsed under its own gravity until it reached a maximum density, at which point it violently rebounded to form our current expanding universe. These diverse models all point toward a common shift in our understanding. The idea of creation from nothing is being replaced by a universe in a state of perpetual transition. While theories of a previous universe are compelling, recent observations suggest that the next cosmic transition might be closer than we thought. For decades, we assumed dark energy was a constant force that would push galaxies apart forever. But new data from the Dark Energy Spectroscopic Instrument, or DESI, has revealed that the behavior of dark energy is changing. Analyzing millions of galaxies, evidence shows dark energy has weakened over billions of years. It is not an unchanging constant. If it continues to decay, it will lose its battle against gravity. The cosmos will stop expanding and contract toward a final big crunch. The weakening of dark energy suggests that cosmic acceleration is not a permanent state. If this decay continues, gravity could eventually overtake the expansion, drawing all matter back toward a big crunch. This possibility reframes our entire history. When we study the cosmic web, we may not be looking at a one-time event, but a massive recycling process. The intense pressure and heat generated by a future Big Crunch would create the exact conditions needed to trigger a new Big Bang. Under these laws of transition, the concept of a beginning disappears. The end of our timeline becomes indistinguishable from its start. To understand how the universe will ultimately end, we must return to its beginning and ask the starting question: did anything exist before the universe?